Okay, here we have an overall view of the BBQ boiler system. I haven't stacked it with really any wood yet, but here we have the boiler tube, which is just an old piece of steam pipe. I've measured the volume of it, which comes out to be about 4 bottles of beer. I've pumped 2.5 or 3 bottles back in by way of this small hand pump. And I think you might be able to see on here. You can see the water go through the tube as I bring it up. Of course, it's out of prime right now, so it's not pumping so good, but it will. There we go. And then we have, attached to the boiler, I've made a small manifold. I have a pressure gauge. I have a 3/8 valve here, which goes to a 3-way splitter, and 3 Vacon venturi pumps. I'm using them as steam jet ejectors. I got a deal on them. They are plumbed in series, so I've got, you can see there's the main pump, and it's got steam blowing through it, which creates a vacuum on this leg, which goes back to the evaporator. But then I have 2 more ejectors pulling on the exhaust from this first ejector. So that way I'm able to increase the power that these guys are actually rated for, and they're only rated for 20 inches of mercury, and I'm getting 25 to 27 depending on various conditions. Below that we also have another line coming off the small valve. This is definitely less than ideal, but that controls this small Tesla turbine that I got from Glenn Turner. And that lays out pretty much everything that's done at the moment. The next parts that have to go on are an atomizer. I have to drill and tap a hole in the acrylic and put on, I'll probably cut that down a little bit, put on this atomizing unit. It'll go through, and this atomizing spray head here, which just came from an insecticide sprayer. The tube is lamp tube, and that just happens to fit 1/4-inch MPT fittings like most of the rest of my stuff, the hose barbs, and so that was very convenient. And then for that will return water to the evaporator, and then I'm getting ready to drill out this fitting so that it'll be just large enough to accept the end of this tube, and that'll go up in there, so I can screw that in through the acrylic and attach another hose barb here to attach down, 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 down these 2 tubes coming through my now filthy cooler. Anyway, here's an overall of the cooler, just a standard cooler. I've drilled 2 holes in the back to accept this 1/4-inch ID clear tubing, which is handy for the demonstration purposes. Now, I don't know whether I have enough coil inside of this cooler to really do an effective job of cooling, but I'm just trying to show the basic principle here. Anyway, coolant, cold water that is chilled in the evaporator comes in through this tube, coils around the bottom, and then it transfers and goes back up to the top, so that I will be cooling both from the top and the bottom of the cooler. I'm sure I could do a better job with heat exchange absorption there, but time and budget being what they are, that's the way it is. But I guess in the end, for this prototype, what I will do then is drill a couple of holes through the back, or else I'm considering drilling or cutting a large hole in this top, so that I can actually sink the whole evaporator unit down into the center, and then it would hang on the lip there. which would be kind of convenient. It takes some height out of it and gets it into about the right location, and yeah, it would be handy. Ultimately, this boiler will be fired by sunlight, which we will collect on some kind of a light tent structure, like, you know, you see these standard tents in farmers markets and stuff like that. I think I'm going to try and adapt a Fresnel reflector to attach to this thing somehow. And then we will circulate a heat transfer fluid from the collector down to boiler and put it into the pipe with another heat exchange device of some sort. So anyway, that's kind of the overall view. Oh, I should also mention the exhaust from the turbine here. This is coming down and I've got it blowing into the air intake on the grill. So when I run the turbine, I will actually be increasing the temperature in the grill by inducing more airflow. So I think that will help keep our pressure and temperature up, even though we're putting various loads on it. I've also tried to do the same with the blowdown valve, so that way, you know, when I do have to let off pressure or whatever, I can put it back into the firebox if need be. Well, that's it.